Hey, what's up everyone? Welcome to this new chapter of my free SwiftUI training course. So last time we went over all of the basics of SwiftUI. I showed you what were the important protocols, the important types, what was the overall structure of a SwiftUI app, and we compared that structure with the one you would have in a UIKit app. And for this second chapter, we are going to go over another very big and very important part of SwiftUI, which is its layout system. So how does SwiftUI layout its views on the screen? Is it different from the way UIKit does it? Spoiler alert, it is. And so we're going to see what are the differences and why they're important. And that's basically going to be my goal for this session, which should last between 1 and 2 hours, I would say. So before we start, I'm checking my note to make sure I don't forget to tell you anything. So first thing, you have a link in the description to the code, which is on GitHub, and it can be useful to download it because inside the project, so it's the project finished that we will have at the end of the session, but you have the assets we're going to use, so images and text that are a bit long, so you might want to download them so that you can use them whenever you need, especially if you are following live. Also, if you are following live, don't forget that a good part of the fun of a live is that you can ask questions directly on the chat. If you have any question, don't hesitate to ask. I will do my best to answer it. And never forget that if you had a question while you were watching live, there is a very good chance that people watching the replay are having the exact same questions. And so by asking them and allowing me to answer them, you're doing a big service to the people who are watching the replay. Finally, this training course on SwiftUI is provided for free because I want everyone to be able to access it, regardless of whether you have money to spend on it or not. However, I've set up a page on Buy Me a Coffee if you want to leave me a tip to support my content creation. So you've got the link in the bottom left corner of the screen. You also have the link in the description. And if you leave a tip during the live, your name will actually be displayed on the stream. So that's pretty cool, and I managed to set it up correctly. So it should work if you want to give it a try. And I think I've said everything I wanted. So let's get started. And let's start by creating a project so that we start from a clean and fresh place. Let me also get all the windows in check on my end. So I'm creating an iOS app, so just like last time. I'm gonna call it Swift. I'm gonna call it Discovering the Layout System. Okay. So for the interface, make sure you select SwiftUI. You don't have a choice for the language, it's Swift. By the way, we've seen last time why Swift's features are like so much like intertwined with how SwiftUI works, and basically we've seen why SwiftUI wouldn't have been possible with a language like Objective-C. Finally, don't check use core data or include tests. We're not going to use that for now. The GitHub is returning a 404. Is it marked as a private repo? Did I make it a private repo? If I did that, I am so sorry. Let me check because I'm going to fix it right now. Okay. Change visibility. It is private. I'm so sorry. Okay, make this repo public. I need to receive a password via SMS. My phone is is recording, but thanks to iCloud, I was able to get the OTP. Okay, now the repo should be public. Okay, let me know if it works. Sorry for that small hiccup, but thanks a lot for pointing it out. Okay, so I'm creating the project on my desktop. I'm going to cancel that warning just because I didn't put my name and email in Git. Okay, so just like last time, we have the project created. So remember, we have two files, the app and the content view. I'm going to close this inspector. We're not going to use it. And what are we going to implement? We need something to implement to discover how SwiftUI's layout system works. And I figured a good example would be to implement a product page, just like the one you would find on the Amazon app, for instance, so where you will have a picture, a title, subtitle, some ratings, a very long text, basically the kind of UI that is both realistic, meaning that there's a good chance you will need to implement something like that if you ever work on a SwiftUI app, but also complex enough that we start to use the critical mass of components where we can learn some really interesting insights. So as last time, I have a script with everything I want to tell you. So when I'm looking to my left, I'm not looking at something else. I'm just looking at my script to make sure I don't forget anything. So we're going to start by the most simple thing we can put in a view. So I'm removing everything in the body. I'm also making some extra space for the code, so like that. And so in the body, I'm going to put a text. Remember from last time, text is the SwiftUI view we use to display, as its name suggests, text. So to display a string on the screen. So we need a title. We need a title for our product. And basically, if you've been looking on GitHub, you've seen that I used, I was about to say an old video game. It's from 2008, 2019, 2018 or 19, but it was more recent when I created this material. So it was from the game Pokemon Let's Go Pikachu. Okay, I've written some text on the screen. This seems simple, but there are some remarks that we can already make and that are interesting, especially if we compare with how a similar use case would have worked with UIKit. So first, we can notice that the text is displaying from the center of the screen. That is very different from what we see in UIKit, because in UIKit, the origin of a view is on the top left corner. So in UIKit, if we had just added a view, I won't say like with the default settings, we would expect it to start showing up at the top left corner, meaning if we had put a view at 0, 0 coordinate in UIKit, it would display from the top left corner, at least with a left to right language. And here it displays from the center. We'll see soon why this is significant and why this is actually quite useful. Another thing I want to show you is the space that the text actually takes. So for that, I'm looking, yes. So you see, you need to click in this little button here. So by default, it was on the top left. So the one called Live. And you want to put it in selectable. And what changes when you put the preview in selectable is that, as you can see, when I go over a part of the code, the corresponding widget on the view gets highlighted. And so here the text view gets not circled, but gets like squared. I don't know how we say, like, gets enclosed by this blue border. I'm going to zoom a little bit also so that everyone can see it, something like that. Okay. Why am I showing you this? Because you can notice that the text only takes the space it needs. And this is very significant because, as we're going to see in this chapter, as we're going to see more and more in this chapter, there is a whole variety of SwiftUI views which are called fitting views, and they're called fitting views because they will take the size that fits their content, nothing more and nothing less. So we are starting to see two interesting characteristics of these views. They display from the center of the space that's available to them, and they only take the space, the screen real estate that they need. We'll see, of course, that it gets a bit more complicated when we start to introduce a more complex view hierarchy than just having a text. Talking about that, we're going to style that text a bit, because we've seen last time how to do it. So I'm going to do it very simply. I'm going to set a font on my text, and that font will be headlined. So it's a font that is predefined in iOS. And you can see that now the text has become bold, because this is how the headline text style is set. Okay, I was about to say, let's add another text, but before we add another text, we need to do something, because if I actually add another text, like for instance, a text that says, okay, it's a Nintendo Switch game, so like that, you can see that nothing has appeared on the preview. However, I now have a second preview, and the reason is because the body now is returning two views, but without the logic to say how they should be grouped, how they should be composed. And so by default, the preview considers that these are like two unrelated views and display them into two previews. We want to say that the views should be on top of each other, and to do that, this is when we start to introduce stacks. So if you've read a few things about SwiftUI, there is a very good chance that you've already heard about V stacks and H stacks. We're going to use a V stack here. So V, as you've guessed, stands for vertical. So to do it, we could do it fully in code, but there is also a shortcut in Xcode. So if you do Command plus click on the SwiftUI view, you can see this contextual menu that appears, and this menu has some actions that are specific to SwiftUI view, like embedding in HTag, VStack, or ZStack, embedding in list, embedding in a group, which is a logical container with no layout impact, making it a conditional, so putting it into a if, repeat, which means embedding it into a for each, just embedding, which puts whatever container and then you replace it by whatever you want. Here we are going to use embed in VStack, and you can see it did the job of putting it into a VStack. It's just a little helper. You can absolutely type it out and move the code yourself. I just wanted to point out that this is possible. And so I'm going to move the text inside the VStack, so the second text inside the VStack. Now we can see the two views are being displayed on top of each other. Hey, good evening, Steph. So I'm going to give it a style to this second text so that it is easy to differentiate it. And so this one will be sub headline. So you can see it's become a little bit smaller because of that style. And now I guess I want to focus a little bit on the VStack. So first thing, I want to show you it's not what I wanted to show you. I think initially in the code, I was supposed to have set a padding over the view, and I wanted to highlight the fact that setting a padding on the text inside the VStack or on the VStack itself is not the same thing. So let's suppose that this padding had been there since the beginning. So padding, we've seen it last time, it's a modifier that you can add to any view, and it will add some extra spacing around the view. What's interesting is that with this behavior of the preview that highlights the frame that the view occupies, we can better understand how padding works. Because as you can see, when there is no padding, the text takes only the space it needs. And when we add the padding around it, so we have a new view. Remember last time when you add a modifier, you actually encapsulate the view you call it on into a new view with the behavior that the modifier defines. So we have this new view, which is the original text with a padding around it, and this padding added some extra space on all edges, so leading, trailing, top, and bottom. we can notice that it's not the same thing for the second text. And if we take a look at the VStack, we can see that the first text has a lot more room to breathe inside the VStack because of the padding, but that's not necessarily what we want. Actually, here this is not what I want. I would like the padding to be at the level of the VStack, so I move it, and now we can see that inside the VStack, the two texts are back to taking only the space that they need, but the VStack itself has gained a bit of padding around it. So here, the takeaway, the thing you should take away from it is that it's important where you call a modifier with regard to the layout system. Calling padding on the VStack or calling padding on the text inside of it is not the same thing. And something that's interesting is that I'm going to call padding on both texts inside the VStack. So let's take a look. You see that we have a bit of spacing around the two texts displayed really on top of each other. And if I comment this padding and then call it on each text, you can see that we get a different behavior because now each text has its own individual padding. This might seem a bit weird what I'm showing, but there is a reason for it. What I wanted to highlight is that a modifier like the modifier padding is not cannot be factored out, meaning that if you call padding once on the VStack, it's not the same thing than calling padding on each of the views inside the VStack. So you cannot have this relationship where you factor it out or you distribute it inside the container. It doesn't work like that, and I wanted to highlight this behavior. I wanted to highlight it more specifically because, as we will see later, there are some modifiers which can be factored out. Actually, let me show you one. For instance, foreground color, we could factor it out, apply it at the level of the VStack, and this modifier would be distributed, we could say, even though it's a little bit of a simplification, but it would be distributed over all of the views inside the VStack. Okay, let me check my script. I wanted to say that we had to add a color modifier, so that's perfect. All right. Now let's take a look at the arguments of the VStack. So first thing we might wonder, what is this VStack actually? Is it a keyword from the language? It doesn't seem to be because, well, the syntax coloring wouldn't be the same. We have this color for keywords and this color for types defined by a framework. So it's not a keyword. It's actually a struct, which is generic over some content that must be a view. And as we are going to see just after, its init takes as its last argument a closure, and so the syntax we see here is actually a result of the trailing closure syntax in Swift, which allows you to pass trailing closure, so a closure at the end of an argument list as just like a scope and not like an argument. And when the closure is the only argument, you don't even need to do that. So actually, this is the same syntax. This is actually what we are doing, but we don't put the parentheses because it makes the code so much easier to read. But I wanted to point out the fact that here we are we are not instantiating, we are initializing the struct VStack. Why didn't I want to say instantiating? Because VStack, like all SwiftUI views, is a struct. So it's not an instance, it's a value. It doesn't have a life cycle of its own. So you're saying, can you put color for more visual comprehension? I can put some colors. Would you like me, for instance, to put some background colors, so like that? And let's see. And like that. I should resume the preview. I hope this is what you were asking for. Let me know if it wasn't that. Okay. Where was I? Yes, let's take a look at the arguments of the init of the VStack. So this is the init. I'm going to do a command click so that we can see it just a little bit bigger on the screen. So what do we have in this init? In this init, we have a few things. We have a first argument, which is the alignment. And we're going to use it just after. It tells us, should the content be aligned on the center of the stack, on the leading edge, or on the trailing edge? And we can see that it has a default value, which is the center. That's why we didn't have to provide that argument. Same thing for the spacing, which is a CG float. So it will be the spacing between the elements in the stack. One thing I want to highlight, because it's quite a tricky behavior, you can notice that the spacing is a float, but it is an optional float with nil as the default value. What's important to note here is that, and I'm looking, yes, it said here, so nil is not the same than 0. If you pass nil as a spacing, or if you provide no spacing and nil is used as a default value, you are actually asking for the stack to choose a default distance for each pair of subviews, basically in a context-aware approach. The reason why I'm highlighting this is that there will be circumstances where that distance, that default distance, will be 0, but not always. And actually, I've seen the case where there was like a mystery distance in some vstacks or hstacks, and the reason was that we actually wanted the distance to be 0, but we hadn't provided a spacing, and so we had this default spacing that was applied, and it's not obvious because by default you have the default spacing, but there is nothing that is drawing your attention to it in the code. And finally, we have a last argument in this init, which is the content. So it's the view that will be inside the stack view. This is a closure that returns some content. This content is a generic argument of the vstack type, and that generic argument must be a view. And that closure is annotated with @viewBuilder, which allows us to use the nice result builder syntax of SwiftUI. I won't go into the details of what ViewBuilder is because I've already focused on it quite a lot on the previous chapter. So if you want a refresher for that, I suggest that you check it out. Of course, if you're watching live, please don't leave. Check it out after. Let me take a look at the chat because I saw some messages. So I see a question. Does it make sense now to deep dive into Combine or better to totally to async await? I don't want to go deep into it because it's not really the topic, but I still want to give it an answer. For simple use cases of a simple SwiftUI app that will just make network requests, basically, async await is probably good enough for most of the use cases. So I would say focus on async await, and when async await is no longer enough, then focus on Combine. But you should find that most of the time for simple use cases of asynchronous code, async await is more than enough. And yeah, you were saying it's better. Indeed, it's better in the sense that for the simple use cases, you get the same result with less code. So that's probably a way to define a better software solution. All right, so that's what I wanted to show about the arguments of the VStack. And so now let's see them in action. So for instance, I can provide an alignment. Didn't want to do all of that. Just provide an alignment. All right. So by default, it's center, and we can see that indeed both views are displayed centered. But if I put it on leading, you should see that now all views are aligned according to their leading edge. And of course, without any surprise, it's the same for trailing. The second argument, so which was spacing. So remember, by default, the value is nil. And in that context, SwiftUI considers that 0 is a good spacing, probably because there is already some slight spacing already included inside the text. But we can provide another value, for instance, 8. And now we can see the spacing appearing. And thanks for a suggestion of putting some colors because the spacing becomes much more clear and visible with the extra colors. Okay. Now let's try something new. Let's try to add an image into this VStack. So this is where we need to use one of the assets I have put on the GitHub project. So here I'm going to create a new image set. I'm going to call it cover because it's going to be the cover of the video game. So I'm trying to do a copy and paste from my other Xcode on my other screen with the finished project. It seems to have worked. Okay. So I'm going to add the image on the top of the VStack. So how do we add an image? I don't remember if we saw images last time, but you use the view image. You can see we have quite a few initializers available. So a name, a UI image, a system name. So we're going to use a few of them. System name, if I'm correct, it's when you want to use SF symbols. UI image is when you already have a UI image that was either created in other parts of your code that uses UIKit by some framework, maybe parts from the network in the context where you already have a UI image. But when you are creating your image inside SwiftUI and your image lies in an asset catalog, you can use this init, which takes the name and the bundle. By default, it's the main bundle. And here, since I have a simple app, I only have the main bundle for my resources. So I will give the name of the image, which is cover. And now hopefully the image should appear. Let's see. I don't see any image appearing, which is not a good sign. So I've called my image cover, all right, I've put it there. What could be wrong? Interesting. I didn't expect something to go wrong at that point, to be honest. So I've named the image cover. I've created it here. I've put the image right here. Let me just check. Okay. Trying to see it in the Finder. Okay, it's even at the right place. Oh, okay. It was just a matter of like some weird cache issue in Xcode. So the image is displayed. Why did I want to display an image? Besides from the fact that we are implementing an Amazon-like product page and we need an image, it's because this image has a very different behavior than the text. So the image view in SwiftUI has a different behavior than the text. Remember, the text would display from the center of the screen and only take the space it needs. And it's very different because the image, it seems to kind of display from the center of the screen, but it takes all the space it needs and even a bit more because it seems to be rendering outside the screen. So that's because by default, an image in SwiftUI will try to render at 100% zoom. So basically, you give it an image of 800 pixels, it will try to display 800 pixels on the screen, regardless of whether there is the space available in the view in which we display it or not. So this is what's happening here actually. So that's an interesting behavior because we can see that this behavior has basically put some part of our text outside of the screen. And the reason why I wanted to show this is to highlight how SwiftUI's layout system works. And the reasoning behind it is that when you put a child view inside a parent view, so like the image in the VStack or the text in the VStack, the parent view, so the VStack, will propose to the child view a size that it can occupy, so the available size. But the child is absolutely free to use it or to refuse it and to ask for more. And this is what is happening right now. So let me take a look at the chat because I see a few remarks. So cleaning the bit folder indeed might have been a good idea. That's an interesting question. Do you think as a beginner iOS developer I should drop learning UIKit and start with SwiftUI, or UIKit is still best option for beginners that want to find a job? I want to answer it because I guess most of the people, I mean a good part of the people watching the training course might wonder about this at some point. So it's very hard to give a clear answer because it depends on so many things. First, I would say take a look at the job offers in your local market, basically in the places where you want to apply, and see what they are actually asking for. Maybe even reach out to them to ask if possible, because you want to optimize for the jobs you want to get. And then I would say if you're a beginner, starting with SwiftUI is probably easier because it's more simple, at least on the surface. But I would say if you start with SwiftUI, whenever you have the chance to understand how UIKit works, try to take it and to understand how UIKit works, because it's still a big part of iOS. So that's kind of the best advice I can give. I don't want to give a clear-cut answer because I don't think that there is one, and I don't want to give a bad advice also. So unfortunately, I will limit myself to this answer, like learn SwiftUI if it's simpler for you, but whenever you have the chance to branch out and understand how something works in UIKit, take that opportunity as a way of understanding how iOS works in general. Okay, and I see that there was some discussion about this, and also for context about SwiftUI adoption, I just want to point out that there are some big iOS apps like Instagram, for instance, that still use a lot of Objective-C. So like their UIKit is still here. It will still be here for some time. It's possible that new apps will be more and more started with SwiftUI, but I guess most developers, when SwiftUI doesn't suit their need, they go back to UIKit. So knowing both seems like important to me if you want to be a strongly skilled iOS developer. All right, let's get back to it. So I was back to saying that the image takes all the space it needs to render at a 100% zoom level, we could say. So I'm going to still keep these things because I want to point out the fact that the layout we ask for the VStack is still kind of respected when you take into account how image behaves, because we still have a trailing alignment, except that since the view, the image has drawn outside the screen, the trailing edge is outside the screen, and so that's why a part of our views are now displayed outside of the screen. If I remove the alignment, so I put it centered, we can see that now everything is back on screen because it's aligned from the center, and the center of the image is on the screen. I'm going to remove all of the arguments of the VStack initializer except for the closure, just to keep things simple. Interesting, we can notice that when we remove the spacing, then basically the text takes a bit more space and goes all the way to the bottom of the screen. I guess this might have something to do with behavior around the safe area, but that's interesting. Okay, so of course this is not what we want. So how do we make the image behave? There are a few things we need to do. First one is to call resizable on it, and it will completely change the behavior of the image, because without I wanted to comment the code. Okay, like that. So without resizable, the image would take all the space it needs to draw at a 100% zoom level, regardless of that space was actually available or not. And when we make it resizable, it becomes different. The image will occupy all of the space that is available to it. If we take a look, we can see that the text is here, the second text is here, the VStack with its padding is around, and so the image is really taking all of the space that's available, but it no longer respects its aspect ratio. How can we force that it respects an aspect ratio? We can use the modifier aspect ratio and pass a content mode. So we get back to things we are used to in UIKit. So we can say fit if we want to fit the available space, meaning that we will not crop the image, but some parts of the available space will not be used. Or we could say fill if we want to fill all of the available space at the price of cropping the image. You can notice that when we say fill, then the image no longer, the image actually fills all the available space, but goes back to drawing outside of the screen. So most of the time, you actually want to use content mode fill because this is what you use, I guess. I'm trying to think like how many times have I used fit and fill. I think I have used fit most of the time. Something interesting is that if you try to switch the order of these two modifiers, you will get a compilation error that says value of type SumView has no member resizable. And I want to point it out because it's quite an interesting error. The reason is that whereas aspect ratio is defined on view, so on an extension of view, so you can call it on any view, it's not the case for resizable. This one is only defined on an image. And that's why we need to call it first, because when we call aspect ratio, if we take a look at the documentation of aspect ratio, you see it returns SumView. And so as soon as we have called aspect ratio, from the Swift compiler point of view, we have lost the fact that it is an image. Actually, the compiler knows it's an image under the hood, but we have lost the fact we can rely on it because it is now inside the opaque return type SumView, and so we cannot call resizable on it. That's why we need to call resizable first. We need to call it at the point where we still have the information accessible that we are calling it on an image and not just any kind of SwiftUI view. So I see a few people saying hi, hey, welcome on the live stream. This question, I want to answer it. Can you mix SwiftUI and UIKit in the same project? Yes, you can. You can quite easily put SwiftUI code in UIKit using UI hosting controller for the simplest approach. And you can also wrap UIKit views in SwiftUI using I've forgotten the name. I've forgotten the name. What is it? I think it's UI view controller representable and UI view representable. So two protocols you make your views conform to. Rather, two protocols that you use to create a struct that will encapsulate a UIKit view, and we will see in a later chapter, so in a few weeks if you're watching the live streams, how to do it. But the good news is that it's actually quite easy, and I've used it a lot of time at work, both approaches, and they work quite well. Honestly, it's one of the parts that Apple has really nailed in order to make it as easy as possible to start using SwiftUI in an existing UIKit app, or to go back to UIKit when something is not available in SwiftUI or available like the way you want it to be. All right, let me see if I've said everything I wanted to tell you. So the modifier aspect ratio. Something interesting that I've learned actually quite recently is that since it's a bit, it's not too complex, but there's still a bit of code in calling this modifier right here. There is actually scaled to fit. And when you take a look at what the doc says about it, it says that this method is equivalent to calling aspect ratio content mode with a nil aspect ratio and the content mode fit. So basically, calling scale to fit is the same thing than calling aspect ratio content mode fit, except that it's a little bit like how should I say, like more like a compact, more condensed syntax. So you can actually use that one. It's a nice little shortcut that is built in into SwiftUI. So you need to support both code bases when you use SwiftUI and UIKit. Well, yes, but you wouldn't implement the same feature using the two languages. You know, some features will be in SwiftUI, some other will be in UIKit, and so each part of your app will be only in one language. And honestly, I haven't seen it is that much of a headache of dealing with both in the same code base. Honestly, I didn't have bad surprises on that end, which is a pretty good thing. Okay, now let's imagine that I want to have a more complex design. I want to have the two texts aligned on the leading edge, so something kind of like that. But I would like the image to be centered with the two text composed together. So basically, I would like this text to be at the center, but both texts aligned on the leading edge. So as you can imagine, it's going to be quite hard to do it in without introducing some weird hacks with the current code I have, but there is a very simple way to put it into place, and it's to introduce a second VStack inside my VStack. So it's something you see a lot in SwiftUI code, like composing VStacks, HTAGs, etc. together is super common. By the way, I realize I haven't shown you HTAGs, so let me show you. If I replace the V with an H, you can see that now we have an horizontal stacks, and so instead of being laid out vertically, now the views are laid out horizontally. So this is how HTAG works, and it's basically has the same initializer structure than a VStack. And we also have ZStack, which puts the views on top of each other. So we can see we have on the back the image, then on top the first text, and then on top the second text. It works similarly as the VStack and the HTAG. Only one difference I want to highlight is that we have more alignment possibilities, because for the VStack there was only one dimension over which things could be aligned. Same thing for the HTAG, but for the VStack there are two dimensions, and so we have these things like bottom leading, for instance, or top trailing, which give us a bit more flexibility, and which can be very useful if, for instance, you need to implement like a nice little badge over a view. You can use a ZStack with a top trailing alignment. And so that's why I wanted to give you this overview of the type of stacks that we have in SwiftUI. All right. So, Joe, you're saying you've just arrived. Thanks for the SwiftUI content. You will check the stream from the beginning. Keep going on your work. Thanks a lot for the support. And you were saying, Florian, you do what you prefer is possible, but I think it's better to only use SwiftUI. It's my preference. I would say do whatever feels best for you. But if I have one advice, so let me display the message so that people watching the replay can also see it. I would say if you feel something is going to be easier in UIKit than it is in SwiftUI, I would still argue that it's better to write the UIKit code, which would be much simpler than a complex, SwiftUI code. My advice would be being pragmatic over being dogmatic, basically. And that's what I try to apply in my own code. I'm not just trying to give good practices that I don't follow. This is what I try to do in my own code. Okay. So back to putting the two texts into a VStack of their own. So this time I'm not going to do command click to refactor. I'm just going to create a second VStack and move the code inside of it. I'm just going to do a cut and paste. So like that. And on this inner VStack, I will set an alignment that will only apply to this inner VStack, which will be leading. And so we have what I wanted to achieve. Now I want to add a new thing. I want to add a grade and evaluations. On the e-commerce website, you often have, how do you say it in English? It's not a grade, it's like the 0 to 5 stars. I don't know how you say it in English. A note, basically, not really a note, a grade. I'm not sure what the name is in English, but we want a rating. That's the word I was looking for, a rating. We want to put a star rating, so from 0 to 5 stars, and we're going to implement it, and we're going to implement it using SF symbol. So yes, rating was the word I was looking for. So we are going to use SF symbol for that. So where do I put the rating? I'm going to put it inside the inner VStack. And so to create an image from SF symbol, we use the image view, but with a different initializer, the one I pointed out just before with system name. And so for a star that is filled out, it's star.fill. If you want to find out the name of SF symbol, you can download the SF symbol app, which is available on Apple's website. You just type SF symbol macOS app on Google, and you should find it. This is where I found out what was the name, so we can see the star has been displayed. So of course, it would be colored in a real app. So to give it a color, we can apply the modifier foreground color, which we saw before, I think. So I'm going to give it a foreground color of yellow. So this is starting to look like the kind of rating that you would find in an e-commerce app. Of course, you don't have just one image. Let me check. I want to check that I'm doing the right view. Okay, perfect. Yes, I'm doing what I want. So we are going to want to display more than one star. So of course we don't want them to be displayed like that on top of each other. It would be super weird, especially because we're going to have up to 5 stars. So this is when we're going to introduce an H tag. So we're going to put an H tag inside our VStack. I'm doing that to show you that there is really no issue with embedding stacks into other stacks. So I create my H tag and I move my 5 images inside this H tag. All right. We can see the views are displayed, and interestingly, we can see that there is a bit of extra spacing that we don't really want that's being added. So normally, if you remember what I showed you just before, you should know what is the reason for this, and you should know how to remove it. So if you're watching the replay, this is one of those times where I suggest that you put the replay on pause and you try to fix the issue by yourself. So how do you remove this extra spacing between the views inside the H tag? I'm not going to make a pause on the live stream, so I will immediately resume and give the answer. And so the answer, we've seen it before with we look at the argument of the initializer of VStack and the initializer of HTAG is following the same logic. There is a spacing argument, which is nil by default, but nil doesn't mean 0. It means whatever spacing makes sense as a default value in the eyes of SwiftUI. Here it's putting some spacing between the views, which makes sense most of the time, but here it's not what we want. And so we want to say we want a spacing of 0, and we say it explicitly. And now it looks more like what we would expect inside an e-commerce app. However, we can notice that by adding all of this code in the body is starting to become more complex. And there are 2 ways that we can start to see that this is becoming more complex. First thing is by the level of nesting. We can see that we have 1, 2, 3 levels of nesting. That's one sign complexity is starting to creep in. But there is a second sign, is the fact that if you look, I can barely fit the entire body on my screen. Now, granted, Xcode doesn't take the full height of my MacBook Pro right now because I made it fit the aspect ratio of the video of the video recording, so 16:9. But I wouldn't gain that much extra space. There is maybe like 20% more available. So when you start to see a SwiftUI view that is either becoming deeply nested or that basically the body doesn't fit on your screen all at once, you might want to start extract some code from the body. And it's actually quite easy to do because the body is just a compute property. It's a it's a compute property that we use a lot in SwiftUI, but it's nothing more than a regular compute property. And so we can actually extract these H tags to another compute property of its own. We can actually do it with the shortcut command click, and then is there an extract subview, for instance? No, extract subview creates really a subview on the type of its own. It's not what I wanted to do. I wanted to see if there was an extract to property, but it seems like there isn't actually. I thought there was one, but I guess I must have like dreamt it. We will do it by hand. It's not a problem. I just see a few messages in the chat. So Tom is saying, I also prefer SwiftUI and use only it. However, some tasks still require UIKit. As I remember, there is no way SwiftUI for changing the color of navigation title, for instance. Yes. And I would say even more generally, like the navigation is much easier to control at a finer grain, with a finer grain on UIKit than on SwiftUI. So for instance, when making like navigations in parts of an app that is made in SwiftUI today, I am still using most of the time UI navigation controller for the navigation because you have more control over the navigation, both on how to customize the navigation view, like you just pointed out, but also on knowing precisely when a navigation will happen, when something is pushed, when something is popped. You have much more control over it in UIKit than in SwiftUI for now. And you were saying you have to use the Appearance API, but indeed it's also like a bit hacky. Like when you need to resort to UIKit to make something work in SwiftUI, it might be a sign that it might be easier to do it in UIKit altogether. What is your most wanted feature for SwiftUI WWDC 2023? So this year. You know what? Actually, I haven't thought about it. I guess I should think about it, but I haven't, and I don't have anything that jumps to mind right now. But it's a very good question, and actually, people who are watching, like I guess you can share if you have one in the chat what your favorite feature would be. But I need to take the time and think about it. Back to the topic of factoring this code out. So I'm going to create a new compute property. So I'm going to call it writings. It's going to be SomeView. Remember, SomeView is the opaque return type that allows us to use the protocol view just like any other type in the return type, even though it has an asserted type with it. And then I move the code of the H tag inside the property. I fix the typo. Okay. And last thing, I need to use that compute property. And so I simply call it inside my body. And voila, it's back. So taking code outside of the body and encapsulating it into a compute property is super easy to do, as we've just done it. You can also do it with a function if you need an argument to build a view, one or more arguments to build a view. And finally, like I showed by mistake before, you can also create really a view of its own when you need it. I would say like start by creating compute properties or functions, and then only create a view when really like, you will reuse it in other places. But don't start creating like here creating a sub view right now wouldn't make sense because it would add more like boilerplate code than needed. Here, I feel we already have the right level of encapsulation for our need right now, which is to display this writing view on a single view. Of course, if we need to implement it on more than one view, then we would create a subview for it. And for iOS 16, yes, navigation stack is indeed much better. However, to use it, you need to support only iOS 16, and that's not the case for most apps. Like the app I work on, for instance, we still support iOS 15. So we cannot use navigation stack for now. All right. What else did I want to show you? So I showed you Oh yes, what if we wanted to show like a different writing, like for instance 4.5, we could use a different UI image like star.leading half.fill. You see now we have 4.5. So of course everything like that is hard coded. In the reality we would need to like take in a number and then translate it by like putting a full star for like every full unit in the rating, and then maybe a half fill if it is like above zero point 0.5 for a given unit. I won't write this code because it becomes like complex like real quick, and it's not what I want to focus on today. I want to focus on the layout system, but I still wanted to point out how you would implement it inside inside a real app. Okay, we can notice what else can we notice? Yeah, something I wanted to point out also is how easy it is to change the order of things in SwiftUI. So for instance, if I take the ratings and I want them for some reason to be between the image and the toText, I could just take the call to the property, move it here in the VStack on the top. That's it, it's moved. It looks a bit stupid what I've just done, but what I wanted to point out is the fact that if you wanted to do the same thing in a storyboard that uses auto layout, or even in like views defined in code in UIKit but that use auto layout, it wouldn't probably be as easy as simply moving one piece of code around in the view hierarchy. You would need to also move the constraints. Here, because of the way SwiftUI's layout system works, we don't have this notion of constraint, we don't have that concept, and it makes it easier because when we move the view, we also kind of move its positioning logic with it. It's a bit of a simplification, but you get what I mean. We can easily move views around and the layout system will adapt. It might not adapt like we want, so we might need to like change a few things, but still it's much easier to move things around than when we were using than if we had been using auto layout. Of course, there are cases in SwiftUI when you start to do complex things where it becomes less easy to move things around. Here, it's still a simple example, but you get the idea, you get the point I wanted to make. Let me put the ratings back to where it is. Interesting question. Are you working on iOS apps only? Have you done macOS apps? I've only worked on iOS apps and I've never done macOS apps except one time working on the port of an iOS app to the Mac, but via Mac Catalyst. But besides that, no, I've done like mostly iOS apps all my career. All right. So let's do something next. Let's add a very, very, very long text. So before I add this very long text, I'm going to want to make the image take a little bit less space because right now there is like no space available to display a long text. So how could I do it? How could I tell the image don't take more than that amount of space? You use a modifier that's called frame. Now, this can very easily get confusing when you already know UIKit, because in UIKit there is also this idea of a frame for a view. But frame in UIKit is not the same as frame in SwiftUI. Remember when I told you earlier that the parent view will propose a size to its child view. This is what the modifier frame allows us to interact with. So by using this modifier, I can force the VStack to only offer a height of 350 to its child view. And we can see that the child view respected it because I've been using resizable. But let's see, if I remove resizable, we can see that now the frame as given is no longer respected by the child view, but we see something very interesting. It's that The VStack offered a frame with 350 as a max height to the image. The image chose to disregard it and to draw outside of this frame, but we can see that that wasn't sent back to the VStack. The VStack kept assuming that the image only used what it had offered to it, and so it kept using that information for laying out the rest of its child views. And we can see that it leads to an interesting UI layout. And I wanted to point out this example because it's a great way to see that the frame is not the frame in SwiftUI is not the actual space that the view will occupy. It is the space we have suggested to the view that it should occupy at the maximum. But the view is free to disrespect that advice, which is very different than UIKit world, because in UIKit, the frame is the source of truth for the amount of space that the view is using. So what is its origin, what is its height, what is its width. Very different in SwiftUI, and it can be extremely confusing when you see a view that doesn't respect its frame. It makes sense in the logic of SwiftUI's layout system, layout algorithm. All right. Did I want to show you anything else? No, this is when we're going to start to introduce a few long texts. So I don't want to put a lot of text. I don't want my code to be just like a multi-line text. So I'm going to introduce a localizable file. So I create a strings file. Yes, it's that one. Strings file. So localizable.strings. I'm going to copy and paste from the finished project. So what I'm copying and pasting is what you already have in the GitHub repo. So it's title, subtitles I've already used, and then description, which is the very long text. This way I can use it inside the SwiftUI view. So I'm going to update the text so that it uses the localizable file. So remember, we saw it last time. When you pass in a text string to the text view, it will try to see if this text is a key that is set inside the localizable file. So here it's the case, and so it's using it. This one, I called it subtitle. So like that. All right. And then I'm going to introduce my third text, which will be the description, and which is much bigger. Okay, so I'm going to give it a font just to be like the other ones, even though by default I think it has the body, like the body text style. Okay, we can notice that there is not enough space to draw all the text on the screen. And we can notice that the way text behaves in that case is kind of like a UI label would behave, which is that it truncates the text by adding an ellipsis at the point where there is no more text, no more room available on the screen to display the text. Trying to make it a little bit like bigger. Okay. The question is, of course, it's not what we want. What we want is to display the text in its entirety and have a way to scroll, to have a scroll view so that the user can scroll just like you would scroll on a product page in the Amazon app. And this is one of the moments where SwiftUI really shines, because we'll see that it is much easier to introduce a scroll view in SwiftUI than it is in UIKit. But just like last time, this is one of the moments where if you're watching the replay, I suggest that you pause the replay and you actually try to put this VStack into a scroll view by yourself, because normally if you've been following, you have all the information you need to do it by yourself. So give it a try, and if after a few minutes you haven't found the solution, then replay the video, relaunch the video, and I will give you the solution. If you're watching live, I'm going to immediately show you how you can do it. So first thing we need to ask is, what do we want to embed in the scroll view? Because we could only embed the text in a scroll view. That would be absolutely reasonable. But we want the entire profile page to scroll, because this is the UX that users have been accustomed to. This is how most e-commerce app works, how most e-commerce apps work. So to do it, we need to embed the VStack in a scroll view. We can do it using the helper in Xcode. This way we don't have to manually move the code. So here you would choose embed, because there is no embed in scroll view among the shortcuts, but we can just do embed. You see it writes container, but there is no SwiftUI view called container. We are meant to replace it with the container we want to use, and we want to use a scroll view as the container. You can see that things have changed. Now the text is being displayed a bit more, it's going all the way into the safe area, and if I go into the live preview, you can see that we can scroll the text. So this is actually all that's needed to embed some content in a scroll view in SwiftUI. And if you've been using UIKit a lot, this is definitely one of these moments where you're like, yeah, actually SwiftUI is pretty cool, because doing the same thing in UIKit would have taken a bit more work, and there would have been one or two times where there was like a lot of room to make a mistake and just not understand how it works. Here with SwiftUI, it's super easy. And one of the reasons why it's so easy is because SwiftUI's layout system allows SwiftUI to know very easily what is the size of all the views it displays. And once it has this information, it's very easy to set up a scroll view. One thing I want to point out is what would happen if I were to comment the text. You can see we see a very different behavior, because when we didn't have the scroll view, so if we only had, I'm going to replace scroll view by group, because group is a container with no layout logic. So it's just like putting nothing. But if I wanted to put nothing, I will need to put to take the code outside of I need to comment like everything, and it's a bit like of a hassle. So I'm just using a group, but using a group is the same as using nothing as far as the layout is concerned. You can see that when I use the group or I use nothing, the view, the VStack is drawn from the center of the screen. That's logic. That's what I've been telling you since the beginning, that SwiftUI, most views in SwiftUI by default, they draw themselves at the center of the space that's available to them. That's not true for all views. There are a few exceptions, like for instance, scroll view. Scroll view will display its content from the top of the screen, which kind of makes sense, because if you started scrolling from the center, it would feel more weird than anything else. But it's something to have in mind, and it's something that can be also useful. Like if you create like a view which is supposed to be a screen of your app, it can be most of the time very useful to put it inside a scroll view. This way it becomes you make sure the content is accessible regardless of the size of the device, because on smaller devices you have less room to display things, and by doing so you also put your content at the top of the screen by default, and sometimes it can be actually a behavior that you want, and so it can be useful to use a scroll view to get that behavior. By the way, if we didn't have a scroll view and we wanted to have the behavior of putting the view at the top of the screen, we could have used a view that is called a spacer, and spacer. So I need to put it inside the group and not okay, yes, I've put it there. Oh, it's because since the group has really like no logic, I need to put it into a VStack, because the group has no like a grouping logic. It does nothing basically. You can see that with the spacer, now the view displays from the top, so I can remove it and then add it. And the way a spacer works is that it's going to take all of the space that's available. So if you want to push some content either at the top of the screen or at the bottom of the screen or at the trailing edge or the leading edge, you can use a spacer. It's a way to say, okay, I want to fill whatever space is available to me. Another thing I can show you when you want to fill all of the space available, rather than using a spacer, you can use a variant of the frame modifier. So you can see there are two frame modifiers. There is the one we've used, which takes width, height, and alignment. But there is also another one with min width, ideal width, max width, etc. And you could use this one, for instance, and say here max width infinity. And you can see that now the VStack takes all the space available to it for the width, so for the horizontal dimension. You can see it doesn't use it because that's interesting, because the VStack takes all the space available, but its content doesn't need it. So actually that space isn't used to draw anything, but the VStack still occupies that space. But if I move my modifier, for instance, to this text right here, we can see that now it's become very different because the text takes all the space available on the width and it gives a very different result alignment wise, because the text displays itself centered inside all of the width that's available. The leading alignment is still applied because here the leading edge are still aligned, but inside the extra space the text is aligned on the center. But you can change this. So by default, it's center, but you can put leading if you want it to go all the way to the left, or trailing if you want it to go all the way to the right. And I wanted to show this because this modifier frame with the max width or the max height can be useful. Most of the time you kind of use more, I guess you use more often the max width than the max height, because the use case where you need something to fill all the width of the screen is more common than filling all the height of the screen, especially if you work on an iPhone. But it's a good trick to know. That's why I wanted to mention it. Okay, let me go back to how the code was when I had embedded everything inside a scroll view. Okay. So we have implemented a scroll view, but what if we didn't stop at one scroll view? What if we put another scroll view inside this scroll view to implement here a carousel that you can basically scroll horizontally, that displays, of course, the cover, but also some pictures of the game. So let's implement it. So I'm going to add a few more assets in my asset catalog. So these images are available in the GitHub repo. I've been able to do a drag and drop from the finished Xcode project. I'm very glad that it worked. So I've introduced 3 images, image 0, image 1, image 2. And we're going to use them in code to implement a carousel. So this time I'm not going to get caught. I'm going to do a clean build folder so that the preview knows about the images I've added. Okay. And we're going to implement that carousel. We're going to do it. Let me get a bit more room for the code. We're going to do it inside a compute property, because I can already anticipate there will be a bit of code, and if I were to put it all in the body, it would make the body too complex. So I'm creating this property images. All right. I will use it immediately. So for now, I need to provide something. I will just call it empty view for now. So I need to use it somewhere. Where shall I display the images? Actually, the images, they will be displayed here. So what I want to do is put the image that I have for now inside my images and replace this right here with images. So I should have the same code than before. Okay, I still get the same result on the screen. But now we have a nice place to start implementing the carousel. So first thing, we need to add more images. And I said I wanted to lay out these images horizontally. So first step is to embed the single images we have for now inside an H tag. And then I'm going to start adding more images. So I could add the images by hand and do things like image-0. So I add the first one, I make it resizable, I make it scale to fit, for instance. Okay, so it gets displayed. Then I copy and paste it. Same thing for image 1, etc., etc. But even though I can do it, and since there are only a few images, it's not a big of an issue. In a real app, you never know in advance how many images there will be for each product. The number of images probably changes depending on the product. So you need a way to iterate over an arbitrary number of images. And this is when I'm going to introduce the for each view. So for each is a view. Don't get fooled by the name, it's called for each. It's not like the for loop, which is how do you call it? A control flow structure. For each is a view that encapsulates that control flow. How does it work? We saw last time that View Builder allows us to turn some simple control flow instructions like if, for instance, into views. For each does kind of the same thing. It is a view that encapsulates the fact that we iterate over a sequence to build a more complex view. Before I create the for each by hand, let me see what happens if I do the command click and repeat, because I want to see what happens. Unfortunately, the repeat is below, like is outside the screen, but I'm choosing the option repeat. Okay, so it just puts it inside a for each. So here I will want my for each to go over the integers 0, 1, and 2, because let's check how many images did I add. Yes, 0, 1, and 2. So the way to do it is to iterate over 0 up to 3, and 3 excluded. So this way we have 0, 1, and 2. Of course, I'm going to remove that. So we can see the same image is being displayed 3 times, but of course now we have access to the item that's being iterated. So here it's just the integers 0, 1, and 2, and we can use them inside the closure we pass to for each. And I'm going to use it here with string interpolation, like that. And now we have our 3 images, very small for now, but we're going to deal with that. But first thing, this is the first time we use a loop inside a SwiftUI view, so I want to really make sure I explain it. And so we've used this for each that allows us to iterate over a sequence and then build views by using the elements of that sequence. So here we iterated over the elements of the integer sequence 0, 1, 2 to build the 3 image views with the name image-0-1-2. So it's a simple example of how you would build more complex views by iterating over more complex sequences. And we will see I guess in a later chapter, how we deal with more complex sequences. Okay. So we've created the image. We need to resize them to call scale to fit. So we've done all of that. Let me just align the code correctly. By the way, the little mistake I made, you see, I've removed the dot. The code still builds, but if you were to run it, it will probably crash because instead of calling scale to fit on the view that's above, you are now calling it on self which probably regenerates the body, etc., etc., etc. And so you've actually triggered an infinite recursion. You can see everything is crashing just because I have forgotten the little dot. So this is the little mistake in SwiftUI that can literally crash your app. And what sucks is that the code builds, so this mistake isn't caught at compile time. So quite the tricky mistake. You want to watch out for it. I hope I can make the preview rework again because it's gonna be, yes, perfect. It's reworking again. Okay. Okay, perfect. So we've created the DH tag. Now we want to put it inside a scroll view. So for that, just like before, we do command embed and we create our scroll view, except that this time we want an horizontal scroll view. So we do it by setting the axis argument. So it can be horizontal or vertical or both because it's an option set. So we could provide both values, but here I'm only interested in the horizontal axis. Okay. Oh, and then, okay, so you don't actually, there is no external name for that one. All right, so we have the behavior. I mean, it's working. We have an horizontal scrolling, scroll view inside a vertical scrolling scroll view, and we've managed to implement it in a way that is very simple compared to the UIKit implementation, because putting a scroll view inside a scroll view in UIKit, you can do it, but I don't doubt the fact that it must be quite complex and there must be quite a lot of occasions to do something wrong. Let me check if I wanted to show you something else on that topic. I guess I could improve a little bit. Yes, so this frame right here, we could also apply it to the images. This way it's going to be a little bit nicer. Perfect. Okay, now what if we wanted to add a nice little animation to show that you can scroll, because it might not be clear that actually this is a part of a screenshot of the game. By the way, this isn't like a great UI design. I'm not suggesting you implement your UI that way. It's just the most simple I could come up with. But with this UI design, it's not clear that you can scroll. A good UI design would make it more clear. But since we don't have a good UI design, we're going to do the next best thing, which is to programmatically scroll a bit to show that indeed you can scroll. And this will allow me to show you how to interact with a scroll view in SwiftUI, and also how to interact with a view in SwiftUI, because the pattern we're going to see applies to more than just scroll views. I see a comment in the chat. You're saying download each from internet with loading indicator for each in parallel. So yes, if you needed to download the images from the internet, this is what you would do indeed. Here we are in a simple case, we could say, because the image are static assets, because the goal here is to focus more on the logic of the layout system rather than how to download and display elements on the UI asynchronously. But that's a very good remark. Okay, so how can we interact with the scroll view in our code? I said that I want to make the scroll view scroll when the view appears. So running some code when the view appears is actually quite easy. There is a modifier for it, which is called onAppear. You can call it on basically any view. It takes a closure that will be called when that view appears on the screen. So running code when the scroll view appears, no problem, we've just taken care of it. But inside the closure we pass to onAppear, how can we interact with the scroll view? We need a way to say, okay, I want to ask my scroll view to do something. How can we do it? We could try to do some weird things, like maybe, I don't know, like storing the scroll view inside a variable. This might be the logic you might have if you need to solve the issue and you were thinking like we do in UIKit, like in the imperative world. You need to have a variable that allows you to refer to the object, except that here it's not an object. The scroll view is not an object, it's just a description of what you want, just like any SwiftUI view. So this is not the actual scroll view instance on the screen, it's a description of the scroll view that you want. And so this is not how you would interact with a scroll view in SwiftUI. You wouldn't be storing it inside a local variable. Instead, you're going to do something that feels a bit weird when you come from the imperative world, like iOS used to mostly be before SwiftUI. But the trick we're going to use is actually quite common in functional programming, and it is to wrap the function we are in. So in a way, scroll view, we can see it as a function, and we wrap it into another function. So what will be that function? It will be something called scroll view reader. So scroll view reader is a view that takes an argument, which is a scroll view proxy. And the way this thing works is that inside the closure on appear, we can now interact with the proxy because it's inside the scope. It's the argument of this parent view. And what the scroll view reader will do is that it will take a look at its child views, and if it finds a scroll view, then it will take care of relaying, we could say, the messages we're sending to the proxy. So basically, when we call something on the proxy, the scroll view reader takes notes, basically, and then it looks, okay, do I have a scroll view inside of me? Oh yes, I have one. I will pass it the message, and the way that message is passed is part of the private implementation of SwiftUI, the one we don't have access to, so the part of where the imperative code, the code that makes the side effects that actually do things on the screen are implemented. We don't touch that part of the code. We only use the functional part of SwiftUI, which is its public API. And so when we want to interact with a scroll view, we use a scroll view reader that will allow us to relay messages to the inner scroll view through the proxy that is available as an argument. This is a very functional trick. If you've been accustomed to imperative programming, it feels super weird, but in the functional realm, this is super common. To give an example, this is as common in functional programming as taking a pointer to something is in imperative programming, to give you an idea, or replace pointer by a reference. But because it's basically the same way to solve, it's two different ways to solve the same problem. How do you refer to something? All right, and so on the proxy, we can call methods. There is only one that is actually available. It's scroll to, and we can ask it to scroll to a view. We can see we need an ID to the view. So we haven't set IDs to our views, but on our views, we can set IDs to them that allow us to interact with them. So the image, I gave it the ID cover, and then the images themselves, I gave them an ID which is equal to their name. In real code, you might want to use enums or things that are type safe. Here, I'm doing things that are like stringly typed just to be quick and efficient and minimize the amount of boilerplate. We've seen that the only requirement is for the ID to be hashable, and the string is hashable. And now I can say on my on appear, my proxy should scroll to the ID. So which ID should I use? I should do image 0. So it should scroll to the second view, and it should make it so that, for instance, we have a second argument called anchor, and anchor I will do trailing, and if I remember it correctly, okay, so it did it immediately, but it scrolls so that the trailing edge of the view becomes visible. It might be better if I launch it inside the simulator. So I'm going to try and do that. I hope it won't crash anything because you never know with the simulator. Okay, it's loading. Okay, actually, this is absolutely normal. What happened is because I said it should scroll so that the trailing edge is visible. At no point did I say that this scrolling should be animated. So by default, it's not. But when you write a side effect and anything you write inside the onAppear, inside the closure you pass to the onAppear modifier is a side effect because it will be executed and it will produce an effect. If you want that effect to be animated, you need to pass it to the function with animation, which takes a body, and inside that body, you do your side effect, which should generate an animation. So using with animation is very similar to using UIView.animate in UIKit. And so now, let me see if I can I don't know if there is a way to restart the preview, but I can just relaunch the code in the simulator. So normally we should have seen an animation. Why don't we see an animation? Did I forget anything? Let's see. I'm looking at the finished version of the code just to see what did I miss. Okay, it's probably, I am not sure 100% why it does that, but I would say it's probably because it must be on the very first, like onAppear. Since it's on the very first onAppear, maybe it does the scroll like before the view even like drew for the first time, and so it's more like an initial position than a scroll. That might be why. Anyway, we can fix this by adding a small delay. So for that, I'm resorting to the same kind of code we would write in UIKit. So dispatch queue.main async after. So for the deadline, now plus half a second. And then what should we execute after that time has elapsed? We should execute the code that is here. So like that. Let's see if it fixes it or not. Okay, it fixed it. So you can see now it begins at like the default position and then it scrolls. And you're seeing using task instead of onAppear. And it's interesting, maybe because I guess they must be called at slightly different time in the... what might happen when you do onAppear is that onAppear calls the closure immediately. And so the closure is probably called before the view is drawn the first time on the screen, whereas task creates the task, but the task only starts after the view has been drawn for the first time. You see what I mean? Something interesting is that onAppear, so what does it say? Yes, add an action to perform before this view appears. So onAppear, it's actually the equivalent of view will appear and not view did appear. And so it's logic when we take that into account because it's logic because the scroll was done before the view had appeared. So actually, I'm glad I made this kind of like a mistake because it allowed us to highlight an interesting underlying mechanism of SwiftUI. And so using task would work, but in a way, like it relies on the fact that the task is started after. So if I were to choose, I would kind of rather have the code that explicitly say, okay, there is a small delay, rather than the task that basically relies on how the implementation worked inside of it. You see what I mean? Interestingly, if I were to just make no delay, let's see. Yeah, it also works because it does the same thing than the task modifier. So if you use task for this, at least leave a comment to explain why you're using, because people are kind of used to the fact that task and onAppear should be interchangeable. Here you're showing a case where it's actually it's actually not the case. Okay, so this is kind of nice. I mean, it works as we expect. But it feels a bit weird to leave the UI in this state. So we could also, and this is where it gets slightly slightly ugly, but once we've done the first animation, we could do a second animation, so which would appear something like that. So it would be now, which is the time when the first animation has finished, and I'm adding like 0.4 seconds that time. And when that has elapsed, I want to scroll back to the first view, which is the cover. And now we have, interestingly, what happened? Oh yes, because the second one, I forgot to put it inside a with animation. If I put that back, okay, much better. And now we have this behavior of saying, hey, look, you can scroll, it works. And so first, let me see, is this async? So it's not particularly, no, it's not async because dispatch queue main, I mean, it is async in the sense that it is asynchronous code, meaning code that will be executed at a later point in time, but it doesn't use async await, it doesn't use Swift concurrency. What I wanted to get to was the fact that for now, we are showing this every single time we are opening the view. And imagine if like Amazon were to show you, yes, you can scroll here every time, it would be awful. So we would like to have a mechanism to say, okay, we only want this animation to be shown once and then never again. So this kind of data, if you had nowhere else to store it, you might want to store it in the user defaults. And what I want to show you is how you can interact with the user defaults in SwiftUI. It's a little bit different than the layout system, but it makes a nice little break into this chapter before we go to the last part, but which will also be the most complex part. So how do we encapsulate state inside a SwiftUI view? If you've watched last week, you might remember that we use @state to say that when this property changes, then the view might need to be redrawn, and so the body must be recomputed compared to the previous body to see what has changed and what might need to be redrawn. So we have a property should display animation, which is going to have a default value of true. And so with this code, we have something that is only available at the view level. If we want the source of truth for this to be not some state stored in the view, but rather state stored inside the user defaults, there is actually a property wrapper for this that SwiftUI has implemented built-in, available since iOS 14, if I'm not mistaken. And that property wrapper is called @app_storage. You pass it the key as an argument, because to store in the user default, you need a key. And now the value of should display animation will be read from the user default. And when no value is stored in the user default, it will use the default value, which is true. And so we can use this property inside our code to make the animation run only when should display animation is true, and then set the property to false once the animation has been displayed. And how can we do that? We can do it by inside onAppear using a guard statement to say guard should display animation else return. This way, when should display animation is false, we don't run the animation. And then there is the question of when should we set the variable to false. So we could do it immediately, but if we do it immediately, maybe if the animation didn't have time to display because the user pushed and then popped immediately the view, that kind of thing, potentially the user could not have seen the animation. So the best way to put it would be here at the time where we know that the animation has been fully executed. So let's do it. And now you can see the first time the animation was run. But if I run the app a second time, nothing was run. That's because in the user default, show display animation is now set to false. And so the guard statement leads to this early exit. That was a little side note on how to use user defaults inside a SwiftUI, inside a SwiftUI app. Okay, what did I have next for you? Let's see, do we have the animation playing when we resume the preview? Okay, the animation played in the preview, so it played the first time, but now if I update the preview, the animation will never play again. That's not that great because that might be something we would like to test in the preview. And so I wanted to show you that you can also put an onAppear modifier on the view you create in the preview. And in this onAppear modifier, you can do a lot of things, including interacting with the user default and to say, for instance, I want to remove the object for the key that is here. And so by setting this code, now when the preview is run, so if I run the preview again, you can see that every time the preview is run, the animation should be run. So every time I save my file and I run the preview again, the animation is run every time because now the user default is being reset every time. This might not be the use case it might not be a use case you will need, but what I wanted to highlight is the fact that when you create a preview, you can also use this onAppear modifier on the view you create in the preview, and you can use it to set up some things if it makes sense to make the preview experience better for you. Okay, let me check what else I wanted to tell you. All right, it's the end of the part about the user default, the little like side note about the user defaults. Before we move on to the more complex like use cases of the layout system, when we want to do things that are like more custom than just using HTAG, VStack, etc. I want us to just take a minute and do a recap of everything we've seen and a recap of how the layout system, the layout algorithm of SwiftUI works according to what we've seen up until now. So this mechanism, it works in 3 times, we could say. I've already described them, but I want to recap them. So first time is that the parent view will offer to its child view all the space it has available. The child view gets this data, this available space, and will compute its actual size, taking into account the size that is offered to it, the space available that is offered to it, but also its own needs. The child view can end up taking less space than it was offered, and we've seen it's been the case, for instance, for the text that only took what it needed. It can take exactly what has been offered. That would be the case for a text that is too long, it will truncate, but will try to display as much as possible. But a view can also take more than it was offered, and we've seen it was the case with the image, for instance, that by default would display at a 100% zoom level, regardless of the available space that was given to it. And finally, the child view will let its parent know about how much space it has actually taken. For instance, if a text didn't take all the space available, it lets the parent view know so that the parent view can take that into account when it will let the next child know how much space is available to it. And so that's how the algorithm works. The parent computes the space available, lets the child know, the child decides how much space it wants to take, lets the parent know, and then the parent move on to the next child. And you can basically apply this framework to all of the views we've built up until now, and you should see that this framework should hold true for all the views and all the way to compose views that we've seen for now. Then I want to also recap on the fact that views in SwiftUI, you can put them into two categories, we could say. First, we have fitting views, which have an intrinsic size and only take the space that they need. So we've seen a few fitting views. We've seen, for instance, text, that is a fitting view. We've seen that HTag and VStags are also fitting views in a transitive way, because since they know the size, the intrinsic size of their child, they also know their own intrinsic size that they derive from that of their child. And then we have filling views, which take all the space available to them. We saw one example of it with the scroll view that would take all the space available to it, but there are actually others. One I could show you, it is kind of funny to see. So I'm going to comment this code. One example of filling view are colors, actually, because colors, you can use them as views, and by default, they will take all the space available to them. So here I'm putting the color red as the view in my body, and it takes all the space that is available to the body. It makes sense because a color doesn't really have a size, an intrinsic size of its own, not like a text, because a text, when you have the string and you have the font, you know how much space it takes to display it. It's not the case with a color, and so a color will take all the space available to it. It's the same for a shape. So we haven't seen shapes, for instance, for now, but if I create a rectangle, no, it's better if I do a circle. If I create a circle, it will take all the space available to it also. And this is quite logic when you think about it. When a view has an intrinsic size, it takes only that size, but when it doesn't have one, it tries to take as much space available to it, and it's up to the parent view to constrain it, for lack of a better term, and say, for instance, here I want my circle to only have a width of 100. Interestingly, you can notice that when you have a color red that has no intrinsic size, if you give it a frame of 100, it will only constrain the horizontal dimension and not the vertical dimension. It makes sense because there is no link between the two of them, they are independent. However, when you have a circle, the shape circle is derived from an equation that links the x and y coordinates together, and so by constraining one of these dimensions, you have constrained the other. And finally, we saw an interesting view that could be both fitting and filling. So before I give you the answer, maybe try to see if you can think which is this view that can be both fitting and filling. I'm going to just leave a little bit of a pause so that people watching the live can also take the time to think. But if you're watching the replay, take the pause and try to wonder what is that view. We've seen it actually. And so the answer, this view that can be both fitting and filling, is image, because we saw that when you call image just an image, it is fitting. It still tries to draw at 100%, but at least it has an intrinsic size, and that intrinsic size is the size of its content drawn at a 100% zoom level. But as soon as you make it resizable, it becomes filling, and it tries to occupy all the space available to it. Technically, because when we call a modifier, we return a new view, it's not exactly the same view, but you get this idea that a same base view, for lack of a better term, can become fitting or filling depending on which modifier we apply to it. And we could also argue, actually, that when I took the text and I applied the modifier frame with a max width set at infinity, it had become a filling view in the horizontal dimension. But at least for base views, they are either fitting or fillings, and it's important to have that in mind because this allows you to understand how they will lay out. And fitting and filling, you can also replace it for views with an intrinsic size and views with no intrinsic size. Okay, and I guess we are up for the last part of this chapter, which is custom alignment or advanced alignment. This is the more complex part, but a part that is good to know because the day when you need to implement it, you're glad that you know about it. So I'm going to create a new SwiftUI view because we will have a bit more room to do our custom or advanced alignment, and also because it's the first time actually I think in this training course that we create a new SwiftUI view, and I want to show you that when you create one, so you do Command N for a new file, but you don't do Swift file. I mean you could, but you can choose SwiftUI view, and it will create a SwiftUI view with some boilerplate code already available. So here I'm going to call it advanced layout view, and you can see it added the struct that conforms to view, the preview, and this way I don't have to write it down myself. It's a nice little shortcut. Of course, you can create a basic SwiftUI file, a basic Swift file, and write it down yourself if you want. Okay. What do I need? I think I need one more image. Yes, I need one more image, so it's that one. So I made this training material back when I was using Bitmojis a lot on my thumbnails, and so that's something that is from that point in time, but we're going to use that image. Okay, what do I want? I want to have a view with two VStacks side by side. So I want to have an H stack, and then in this H stack, two VStacks. So like that. In the first VStack, I want to have first text, which will be my Twitter handle, because why not? Okay, so I have the first text. Then I want to have an image. Let me make a bit more space. So this image will be the one I've just added. Of course, let's make it resizable and let's give it a frame with width and height set. So 64 and 64, something like that. Okay. That was for the first VStack, so the left column I'm implementing. And then for the one on the right, so I'm going to say full name, okay? And what is, I've made a few typos. What is this full name? So it's going to be my full name, okay? I'm gonna give it a big font so that the alignment will become a bit different. All right. So we have the views. I have defined the views that will be our playground to have fun with advanced alignments. I guess I will give them also different background colors so that we can see what's happening in a better way. So blue, for instance. Here is going to be yellow. Okay. Here is gonna be red. And here is gonna be green. All right. This gives an idea of what's happening. It will make like the alignment easier to see. So now let's imagine I want to align the first text of the first column with the first text of the second column. This should be quite easy to do. We've seen how to do it before, so if you're watching the replay, once again, try to do it on your own. But if you're watching the live, I will show you how to do it, and we are using the alignment argument with the top alignment. And so you can see that now the top text in the first column has become aligned with the first text in the second column. But what's interesting is that actually we haven't really aligned the first text of the first column with the first text of the second column. What I mean is that we didn't state to SwiftUI that we wanted this text to be aligned with that text. We said to SwiftUI we want the content of the first column to be aligned with the content of the second column. And as it happens, this property, you can derive from it that the content of the first element of the first column will be aligned with the first element of the second column. What I meant to say by that is that the alignment is done without sharing information across the columns. That's the information. That's the point I want to stress. With the alignment system that is available with HStack and VStack, we can only align the child views, but in a global way, meaning that we are saying, okay, all of the children should be aligned in that way. But we cannot align one element in the first child relative to one element in the second child. We cannot make the two child views, the two branches of the tree that represents our view hierarchy, communicate with one another. So, for instance, if I were to ask you to align the text on the top left here with the text on the bottom right, using the alignments in the HStack, we don't really have a way to do it. You're saying padding to full name. You could add a padding, but then you would be putting in magic numbers, and that's not guaranteed to work in all circumstances. And that wouldn't encode the fact that we want a way to encode that we want to align the blue text with the green text. It's impossible to do it because these simple alignments are scoped, we could say, to each of the children of the child views, but there is no way to make them communicate. So how could we? Oh, you're saying to add a padding to make it clear they are not aligned. Yes, why not? Why not? I could add a padding here, and then add another padding there. Okay. Indeed, it makes it easier to see. Great suggestion. So when we want to do that and when we need to do that, we need to create our own alignment guides. So we've actually been using alignment guides. Top, for instance, is a vertical alignment, and we need to create our own. So how can we create our own? So before I start, fair warning, this is, as you can imagine, a very advanced mechanism. We are only going to scratch the surface here. I want to show you a simple use case for this advanced mechanism. I won't go into the details of it, first because I don't know the ins and outs of this mechanism. That's a good thing because it means you don't need to know the ins and outs really well to be a professional SwiftUI developer. By professional, I mean someone who gets a salary from developing apps in SwiftUI. But I'm also saying this to say like it will feel like we're just scratching the surface and then I'm ending the topic. That's on purpose. I just want to draw your attention to the fact that this exists. This exists because there is the limitation I've just highlighted. I want to show you this is the solution so that the way where you encounter that limitation, you know where to look for the solution. So since we're going to do the custom alignment in our VStacks, we're going to extend vertical alignment. So I'm creating this extension, and inside of it, I'm going to create a static constant which will be my custom alignment. I'm going to give it a name that makes sense in the context of the view. So it will be mid account and name. Why did I call it mid account and name? That's weird, actually, because it should be just account and name. I don't remember why I named it that in the solution and in the Xcode project. If I don't remember why, I will update the Xcode project so that there is the correct naming. So account and name, okay, is going to be a vertical alignment. And I need to pass it an argument which is an ID of type alignment ID.type. And to get that, I create an enum inside my extension, which I will call account and name. I will make it conform to this protocol alignment ID so that I can pass it to this vertical alignment. So it expects a type, so I pass the type itself. So it will be account and name.self. And I need to implement the protocol alignment ID, which means that I need to provide a default alignment. So when I don't say anything, how should a view that uses this alignment ID be laid out? And so I have a context as an argument, which is a dictionary. And I'm going to say, okay, I want the top. So by default, I want a top alignment when I don't state anything else. Just going to rewrite the code so that it fits on the screen. It feels a bit weird. I'm going to experiment with it so that it becomes easier to understand what role do these arguments play. Okay. And now we need to use this custom alignment. So where are we going to use it? Since it's a vertical alignment guide, actually we don't have a choice. We can only use it in the HTAG. So here, because the HTAG takes a vertical alignment guide, whereas an HTAG takes a vertical alignment guide, whereas a VStack takes an horizontal alignment guide. Why? Because an HTAG lays out its content from left to right, so the horizontal dimension is managed by the HTAG by itself, but you need to tell it for the vertical dimension where it should position its element, and same thing respectively with horizontal for the VStack. So it will use the account and name alignment. You can see that for now nothing has changed. It makes sense because I said that by default, when I don't use the alignment guide anywhere else, using account and name is the same than using top. So it is still using top. Let me point out the fact that we added some padding. So the top of the first VStack is indeed aligned with the top of the second VStack, but we have some padding. This is a great time to show you that if you call padding before or after setting a background color, it doesn't do the same thing. So I should have made that change earlier, but it's a good thing I didn't because I can highlight that behavior. If you put background first, then you only color the background of the text itself, and then the padding is added. But on the other hand, if you put padding first, then the padding is added, and then what gets colored is the background of both the padding and the text. So the order of the modifier have an importance, especially when you are using modifiers that modify the size, the intrinsic size of the view. Let me make the same change. So here it will make it easier to follow. So we can see that using account and name was the same thing than using top, because here I've stated with this weird syntax, but I've stated that when we use account and name, by default, it's just like having a top alignment. I could use center here, and you see it would. Yes, I need to say that it is the vertical alignment.center. And you can see now it's become aligned according to the center. If I go back to top, we should see a difference. yes, we do see a difference. Okay, and you're saying, interestingly, yes, in frame there is also an alignment, but this one will only align the content with the size that it takes. We've used it when I set max width to a text to show how we could move it from left to right to center of the screen, but indeed we can also use alignment in that context. That's a very good remark. And we are almost there. Now I wanted to have this text here aligned with that text there. And so the way to do it is to call alignment guide on the modifier alignment guide on the first text to say, okay, I'm interested in the alignment guide account and name. And so when that alignment guide is used, here is how you will align the views. And so here we have this syntax. So we have a context. So it's kind of similar to what we saw here. So sometimes you can see context be used as D for dimensions, and also because it makes the code a little bit more compact. And so here I'm saying I want to align with respect to the first baseline of the text. And you want to put the same line of code here on the second text. And now you can see the two texts have become aligned together. So let me make it a bit more visible and let me debrief what I've done. So I've called the modifier alignment guide on both views in each VStack. I passed the same custom alignment guide. So this is what allowed me to communicate an information, a layout information between two branches of the view hierarchy. And I said that, okay, when this alignment guide has been set on a parent view, so here, the way to align this view with whatever else also uses the alignment guide is to use what's called the first text baseline. What's the first text baseline? Let me explain what a baseline is. The baseline is the imaginary line over which your characters are being drawn. So when you want to align text that is not necessarily of the same font size, how could you do it? The way to do it most of the time is to use the baseline, and you can see that it's kind of like if we had aligned the bottom of the characters, except that there are some characters that go below the baseline, like a Q, for instance, or a P. And here there are not that many of them, or it's hard to see, but by aligning the baseline, we basically align the text in an harmonious way, and we have first baseline available, and I would say, yes, last text baseline, because you might want to align the top of the text together or the bottom of the text together. And so if we were to use top inside, it would go back to how it is, and this code here would be completely ignored, because what this modifier says is that when this alignment guide is used, this is how you actually compute the alignment value, so the value, the number, the coordinate at which you should draw the view. And so here, when account and name is used as an alignment guide, the value you should take into account to align the two together is the first baseline of this text and the first baseline of that second text. So I think I delivered on my promise that this would be complex. I guess you might have noticed that I was not as at ease to explain it. It's because it is a very complex topic. But as I told you, fortunately, I never actually needed to go in deep with this topic, which is a good thing because it means that most of the time you don't need to go in deep into this topic. But it's good to know that this topic does exist, that there is this way of taking a finer control over how to align views when you need it. And that mechanism is to create custom alignment guides. Let me see. I see you're saying they are not aligned. Your name is large in 2 lines. And I guess this is what I answered when I explained what the baseline was, because indeed the texts are not aligned. They are aligned respective to their baseline. We could change this. We could say, okay, we actually want to align the center of both texts. And now, let's see. Oh yes, I need to say vertical alignment because there are two centers. There is the center in horizontal alignment and the center in vertical alignment. Okay, and now they are aligned respective to their center. But it's interesting the fact that you said they are not aligned because I guess you instinctively expected the alignment to be respective to the center, but aligned for SwiftUI doesn't mean align with something in particular. It means align with whatever you says it should be aligned with. And so you can say it should be aligned with the center, but you could say it should be aligned with other things like the first text baseline, like I showed in my example. So thanks for this remark because I'm sure other people watching the replay thought of the same thing. And one website I can recommend is a website called SwiftUI Lab, which has some very good articles on how to deal with alignment guides. And actually, I think in the GitHub repo I've put a video which shows like how alignment guides can be used and how you can set several alignment guides modifier with different guides and then change the guide at runtime to change the alignment at runtime. This is also possible. There is a nice video that shows it, and this video comes from that website. So I think it's swiftui-lab.com, and I can recommend all of the articles. They are all very good, but that one in particular on the alignment guide, I can especially recommend it that you check it out after you're done watching this chapter of my training course. And that's actually the end of this chapter. We've reached the end of the chapter. So I was thinking it should be between 1 and 2 hours, but actually it took a bit more than 2 hours. But I'm glad we've finished that chapter and we went through it. So it's quite an important chapter, I think, in the training course. Arguably, since the training course tried to be as short as possible, all chapters are important and they all talk about a very important topic to be proficient at writing SwiftUI. But this one, if you don't get it, it's complicated to be efficient at SwiftUI because if you don't understand really how the layout system works, you're always experimenting and you're never really sure of what you're doing. So I hope that these 2 hours have given you a nice overview of how the SwiftUI layout system works. So if you were to only remember the important part, remember the fitting views and the filling views. Remember the logic for the layout where the parent view offers a size to the child view that can respect it or not, and then lets the parent view know which size it will actually take. These are the really two things I would like you to remember because having these two things in mind really helps you understand how things work, and when something doesn't work like you would expect it to, understand why and hopefully understand how to fix it. One last time, I want to say if you've been watching the live or the replay up until now, so up until the end, thank you for staying. I hope you've enjoyed. Quick reminder that this training session is available entirely for free. But if you've enjoyed it and you want to support and sponsor my content creation, you have a link in the bottom left corner of the screen and also in the description where you can leave a small tip, and it will always help me create better content. A replay will be available immediately after I finish the live. What will be the topic next time? I can tell you that before I end. Next time we will do a to-do list app because it's the basic example that every tutorial does, but if every tutorial does it, it's because there is a reason. It's because it's a great way to grasp a lot of concepts. And so we will see how to deal with how to display lists of data and how to handle data in SwiftUI, and how to handle data flow between parent and child views. That will be the topic of the next chapter that should happen hopefully next Thursday. Thank you for watching. Enjoy the rest of your day, of your evening, depending of where you are in the world and when you watch this replay. And see you next time for the next chapter. Bye bye.